Hey everyone, this is Dr. Walker. This is video 500 on unit vectors. Unit vectors allow us to express vectors in a different way that is oftentimes more convenient, especially when we know information about the components of the vectors. So, unit vectors specify direction. If we are in the Cartesian coordinates, where we have the x, y, and z axes, then we use the unit vectors I, j, and k. I specifies the x direction, j the y direction, and k the z direction. Note that there's this little hat symbol above the unit vector to specify that it is a unit vector. Because unit vectors only specify direction, that means that they have a magnitude or length of 1, which is what I have shown here. So they don't tell us anything about the strength of the vector, just its direction. For instance, if we had a vector, call it vector A, along the y direction, well, the unit vector j would specify the direction of vector A, but it wouldn't tell us anything about its direction. How do we express vectors using unit vector notation? All we do is we write down the components of the vector and we follow it by I hat, j hat, or k hat depending on the direction. An x component would be followed by an I hat to specify that that x component goes along the x direction. As you can see over here, let's say you have this vector ax that points along the x direction. Well, then you would specify it as ax I hat, where ax here is the length of that vector, and I hat is the direction of that vector. Now let's say that you have a vector in 2 dimensions. Well, then you would have the x component, ax I hat, plus the y component, there's a little typo here, ay j hat. So you're adding the x and y components to specify the vector in its entirety. And we know that that's the case because, as we can see from this illustration, if we have the ay vector going up here, the ax vector going to the right, we know that when we add them tip to tail, we do get the vector A. Can you figure out how to express a vector in 3 dimensions in Cartesian coordinate system? Hopefully you got it. In 3 dimensions, we would say ax I hat plus ay j hat plus az k hat to specify this vector in 3 dimensions. We'll see in the next video that expressing vectors in this way makes it a lot easier to add them and to do different operations with them. But first, before we move on to that, let's talk briefly about unit vectors in polar coordinates. In polar coordinates, we use the letter r to represent the length of a vector, and then we use theta to specify its direction. Some books use phi, but I like to use theta. Let's say we have a vector from 0 to the point xy. Its length would be r, which is in italics, and then the vector itself, I put a little arrow here to show that this is a vector in that direction. The vector itself would be r with the vector, and then it would have a direction specified by theta. The magnitude of the x component here, the magnitude of this x component would be r cosine theta because it's adjacent to the theta, and the magnitude of the y component would be r sine theta because it's opposite to theta. So what about the unit vector? Remember, a unit vector only specifies the direction. So this r hat vector here has a certain length. So the r hat vector, so this r right here has a certain length, but r hat, we usually draw a little vector to show, hey, the length of r hat is only 1, but it points in the same direction as the r vector. And some books choose to write the r hat here. That's fine, as long as it is in the same direction as the r vector. In the polar coordinates, we also have a vector theta hat, which points in a direction perpendicular to the r unit vector. So how do we find this unit vector? Well, in general, if you have the vector itself and you know its magnitude, then all you do to find the unit vector is you divide the vector itself by its magnitude. That will be pretty useful later when we get onto the rotation chapters, and we'll have an example in the video that follows.